Why do serverless functions have memory limits? Imagine building a busy city where each building has a set amount of space. If one building takes up too much room, it can block roads or cause traffic jams. That's similar to how serverless functions work in the cloud. These functions are tiny pieces of code that run on demand, without you managing the servers. They need to share resources like memory and processing power with many other functions. Memory limits are set to keep everything running smoothly. Think of it like a rule that each building can only take up a certain amount of space. This prevents any one function from hogging all the resources and slowing down the entire system. Cloud providers run many functions at once on shared hardware. Setting memory limits makes sure each function gets a fair share, so no one dominates and causes problems. Performance is another reason. More memory usually means more CPU power, which can make functions run faster. But if there were no limits, some functions might use too much memory and slow down others. Limits help keep performance predictable and balanced. It's like having speed limits on roads to avoid accidents and traffic jams. Cost is also a big factor. Cloud services charge based on how much memory a function uses and how long it runs. If functions could use unlimited memory, costs could skyrocket. Limiting memory encourages developers to write efficient code that doesn't waste resources. It's a way to keep expenses under control while still getting good performance. System stability is vital too. Without memory limits, a poorly written function with a memory leak could crash the whole platform. Limits act like safety barriers, preventing one faulty function from affecting others or the host system. They also add a layer of security by isolating functions from each other. For backend developers working with APIs, databases, or server-side logic, understanding these limits is key. For example, API endpoints usually need moderate memory, around 250 to 500 megabytes, to handle requests smoothly. Data processing tasks might need more, especially if working with large datasets or complex calculations. To manage memory effectively, developers should test their functions with different settings to find the right balance. Monitoring tools can alert you when memory usage gets close to the limit. You can also optimize your code and dependencies to reduce memory needs. If a task requires more memory than allowed, splitting it into smaller functions is a smart move. In essence, memory limits in serverless functions are there to make sure resources are shared fairly, performance stays steady, costs stay manageable, and the system remains stable. They guide developers to allocate just enough memory for their functions to run efficiently, whether they're handling simple API requests or processing large amounts of data.